Mr. Spencer, you can now come on as a panelist.
Hello, hello.
Hello, hello. All right, well, give us another couple of minutes when a few more people come in. Pretty good turnout today, J-Man, given this time of year, which I'm really excited about. And I guess while we're waiting on everyone to come in, I will extend an apology that we kind of chopped and changed with this. This was going to be a live event, and then it was going to get pushed back to Friday uh, for another live event. But we realized everyone has a really busy schedule this time of year, so we thought we'd cut our losses and have a live webinar. And this way we get to record it and then put it on the website and on our YouTube channel. So everyone wins, and then we've got some pretty amazing events uh, already in the mix for next year.
Hmm. We did try very hard, everyone, to make a live event, but it just wasn't happening this time of year.
We
Mm.
did. And I'll just wait a couple more minutes because we are just a bit before 5 o'clock. So I'll let that click over. But yeah, no, next year's live events I think are going to be bigger and better than this year. So I'm super excited as the one that organises all those events to be hosting them and presenting them for everyone next year. It's going to be super exciting. All right, it's 5 o'clock, Jeremy, so I might get started. Um,
Go for it. Let's do it.
welcome, everyone. This is the first webinar we've done, I believe, since about June. So excuse me if I'm a little bit rusty. I will do my best to try and be the hostess with the mostest. Today, we are joined by one of the other founding directors of Sustainable Builders Alliance, Mr. Jeremy Spencer. Everyone knows him. He doesn't need any introduction. For those who are joining us for the first time, my name's Hamish White. I am one of the founding members of Sustainable Builders Alliance, and I run the events and webinars. And I'm also the director of Sanctum Homes, and I'm going to be hosting today's webinar. In the spirit of reconciliation, we would like to acknowledge the traditional custodians of country throughout Australia and their connections to land, sea, and community. And we pay our respects to elders past, present, and emerging, and extend our respect to all Aboriginal and Torres Strait Islander people today. Now, I've got a few questions to kind of propose to everyone before we get started, and then hopefully Jeremy can answer them as we go through. But can we achieve industry-wide net zero outcomes for new homes? What about embodied carbon? Can we achieve true zero outcomes? Is it feasible today, and what does it take? What are the steps designers, builders, assessors, and others in the industry should be focusing on? And how much does it cost? For 2 decades, Jeremy has been a registered builder, energy assessor, and director at design and build company Positive Footprints. Positive Footprints have won multiple awards for sustainability and work to show that energy efficient, sustainable design and high performance net zero home construction is a cost effective option and can be a mainstream reality. Your rap sheet is huge, Jeremy. An educator, National Sustainability Awards judge, past Design Matters National Director, and creator of the True Zero Carbon Challenge and True Zero Embodied Carbon Spreadsheet. Jeremy is passionate about spreading knowledge on how to build better. Jeremy is also, as I mentioned before, a proud founding director of Sustainable Builders Alliance, and he is the brains behind all the content on our website. And its industry resource roadmap to net zero homes, which is free. It sits on that website, www.thesba.com.au. 2 years ago, Positive Footprints created the Carbon Zero series, homes that not only produce more power than they use, but also minimise embodied carbon and produce enough extra power to also pay back the embodied carbon debt. 2 of these homes have now been built with 12 months of lived-in data, and the results are very impressive, which we're going to hear about today. Today's webinar is brought to you by one of our platinum sponsors, Thermotech Windows and Doors. Thermotech makes superior energy-efficient UPVC windows and doors with advanced German technology, and they actually feature on the projects that Jeremy is going to talk about today. you can get in touch with Thermotech at thermotechwindows.com.au. Today's presentation is going to be a presentation by Jeremy, and there's going to be plenty of time at the end for any Q&A. So without further ado, Jeremy, I'm going to throw it over to you, mate.
Beautiful. All right, let me share a screen and send. Sharing's not turned on. Send request.
All right, let me allow. There we go. Try that now, mate.
That is looking good. All right, let's see. Yep.
All right, and if anyone has any questions, I just want to pop them in the chat down below, and we'll have an opportunity to answer those towards the end.
Let me just. Can you see the presentation, Hamish?
All good, mate. All good to go.
All right. All right. All right. Well, look, thanks everyone for giving up your, what is it, Wednesday afternoon. I'm hoping I can give you a little bit of value for money here. Should be able to, since it was free. So, Sustainable Builders Alliance, all about sharing ideas. So today I'm holding the can, but if you do have any questions, make sure you pop it in the chat, and maybe Hamish, as we go, or at various points, if it makes sense, ask those questions as we go potentially. All right, let's get into this. Mainstreaming net zero homes. So I want to go over a few things today. I want to look at, first of all, start with the impact of housing. Always important to know what the problem that we're trying to solve is, so that we've got a firm foundation. I also want to look at what's possible today and some of the good news there. And then get into the nitty-gritty of how to actually achieve net zero. Now, I'll just be providing an overview today. I won't be going into all of the nuts and bolts, but I'm hoping to, well, I'll be showing a case study of one of our homes, and quickly just a look at the other one as well, on case study and how we achieve net zero and true zero on those, but also touch on what sort of knowledge base is needed to achieve these sorts of outcomes, and also what resources you'll need if you also want to do it, or if others want to do it. And then lastly, we'll get into embodied carbon and true zero. Now, there's pretty ambitious on what I've put in here, Haim. So we'll see how we go for time, and if my voice holds out, or if we need to split this potentially into 2 webinars. If we do, I apologise now. If we do, we'll be stopping at maybe net zero and doing embodied carbon as its own thing. All right. Impact of housing. Let's start with this. 421. Scream at your screen if you know what that is. 421, I looked it up the other day. That's the number of parts per million of carbon dioxide in the atmosphere at the moment, currently. To put in some sort of perspective, I was born back in the dark old days of 1970. Back then when I was born, it was 325 parts per million in the atmosphere. So within part of a human lifespan, we've almost gone up 100 points. And this is a real blink of the eye in sort of geological terms. Also, to put this in some sort of perspective of what this means, the last time that we had this number of 421 parts per million was well back before human history even got going, 3 million years ago, back in the mid-Pliocene, when temperatures were 2.5 to 4 to 5 degrees higher back then. So we're wanting to try and obviously stabilize this number, but I thought I'd start with that little fact for you. Also, maybe just to show you how quick the change is. There's my birthday there, 1970. What you're seeing now is a graph of the carbon dioxide that's been released since the Industrial Revolution from our industry, and has led to all the amazing changes that we've seen, but of course is causing a problem as far as heating the planet. 36 billion tonnes or so is being produced at the moment, and over on the right you can see of that 36 billion tonnes, 39% is related to buildings. Either the operational energy to run buildings or the energy that goes into the materials which we make our buildings from, and the carbon dioxide that gets released from that energy use. So two things come up for me from that. One is that if we do want to flatten this curve and try and change to a more renewable energy mix, the building industry has to be involved in that. If the building industry isn't on board, we're not going to be able to flatten this curve. The second thing it brings up for me is if you are in the building industry, you are in a job that disproportionately has an effect on trying to solve this problem. So you're in somewhat of a privileged position, and your choices matter, the way you run your business matters, and the product that you supply matters. Let's bring it back to homes because that's what the Sustainable Builders Alliance is focused on. That's probably where our special knowledge lies. And let's look at the impact of our homes on this carbon number. So there are two main carbon impacts of our homes. One is operational energy use, and the other one is the embodied carbon in our homes from the embodied energy. That's the energy that it took to create the materials that our houses were made from, and the carbon dioxide got released in using that energy. If we look at operational carbon, first of all, I often use this pie, and I'm going to be using it today again because it's a useful way of looking at where the energy is being used and how we can minimize demand, which is really what we're first focused on when we're trying to create that net zero home. So most of the energy gets used. By the way, what this is, average Australian energy use. This is if you get all of the old homes, all the new homes, all the homes across Australia, put them together, look at where the energy is used in the homes, and this is the way the pie separates out. Most of the energy is used on space conditioning. Water heating is also big, and plug-in appliances as a group is also quite big. Cooking and lighting quite small. Now, in providing this energy, most homes are just drawing it from the grid, and fossil fuels are being burnt to provide these functions in each one of these wedges. And it works out when people do the sums that it's approximately 5 tons of carbon dioxide gets released by every single home every year on average. So you can think of this pie also as being 5 tons of carbon dioxide, and these wedges approximate how it gets split up. This pie also represents the average fuel bill. So the average fuel bill, $2,000+ a year if you combine on a dual fuel home, if you combine your gas bill and your electricity bill, or hopefully if you're all electric today, most homes will be somewhere around that $2,000 mark, and an average energy use of 32 kilowatt hours per day. Again, that's if you converted if all your heating and cooling is also on all electric. If you converted your megajoules to kilowatt hours, added them to your electricity bill, somewhere around there. Now, the good news is, first of all, the bad news is this happens year on year on year. And 5 tons of carbon dioxide, that's each ton of carbon dioxide is about the size of, if you're trying to visualize what that actually means, if you took all of the air out of a standard home, average home in Australia, 230 square meters, and you filled it with carbon dioxide, that house would hold 1 ton of carbon dioxide. So basically it's 5 houses full of carbon dioxide equals 5 tons of carbon dioxide. And that gets released into the atmosphere every year for the life of the home. And homes are long-lived things. So if nothing changed, which we know that it will, and we're trying to make sure that it does, but if nothing changed, that builds up over time. Could be over 50 years, 250 tons of carbon dioxide if nothing changed. The good news is we can get rid of all of this today, and I'll be showing you how we can do that during this talk. The second big pot of carbon dioxide that gets released is in the materials. That's the embodied carbon that we make our homes up of. How much this is a harder number to actually pin down. One group that tried to do it was the University of New South Wales, the Low Carbon Living CRC, and the Low Carbon Institute, who put out a document a few years ago called the Race to Net Zero Carbon, where they looked at, this was a meta-study that looked at studies around the world that calculated embodied carbon also from Australia, normalized between those studies, so they had the same assumptions, to try and answer the question, how much embodied carbon is there per square meter of home? And they came up with the answer of 1.27 tons of carbon dioxide per square meter. And if we consider that average Australian home, 230 square meters at the moment on average, round about there, that's around about 290 tons of carbon dioxide by this metric for each home. So these are huge numbers, quite mind-blowing numbers. To put that in perspective, that's more than twice as heavy as the average home in a waste product that is gone off to the atmosphere even before you hand over the keys. Quite a big impact that we need to get a handle on. On top of that, the demand in Australia is for 200,000 new residents per year. We're a bit below that at the moment, but that's what we're trying to build to keep up with demand. That means every 5 or 6 years or so, we're adding another million homes onto the grid. And we simply can't allow the next million homes that we put on to have the same impact as the last million homes, not just from the carbon point of view, but also if we are actually trying to green Australia, we're trying to put everything onto a grid and green that grid. For that not to cost the earth, we need to limit the demand of the new homes that we're putting into the system. Which is why we, the founding members of Sustainable Builds Alliance, got together to create what we're doing and to try and give you that information. And it is simply this: we want to be able to give you the confidence to build net zero sustainable homes. What does that mean? That means we want you to be able to put a shingle up on your door to say, we sell net zero homes. And when someone comes to you and says, yep, I want one of those, you can say no problems and have the confidence to bring it into the market. Towards that end, on this website, probably the heart of this website is something called the Roadmap to Net Zero Homes. And it's got 5 different steps, and all the information that we put on the website hangs on that scaffold of these 5 steps. And it's simply this, very simple steps. Step 1, good design. Design a home that's designed for its climate using passive solar design, so it needs minimal extra heating and cooling because the climate is doing the heavy lifting. Step 2, choose materials that are low themselves in embodied carbon, vis-a-vis other materials on the market, to try and have a lower impact home when you hand over those keys. Step 3, performance construction. Build the house so that it actually performs to its energy rating in that good design section, and it performs on the ground as it did on the paper in the design office. Step 4, then keep the demand low in the house by making sure that other major things, the appliances that you put in the home, are also energy efficient. And then the last step is to put on photovoltaics for either net zero, producing as much power over the year as you use, or potentially true zero, also accounting for the embodied carbon in the home and trying to offset for that. And job done if you can do all that. We'll talk a little bit more about offsetting maybe just at the end, because it's not quite as straightforward as I made it sound just there. Okay, let's get into, that's what Sustainable Builds Alliance is trying to do, but let's look at what's possible, and I'll show you a couple of homes that we've done, and also then the case study home that I want to show you today, and then we'll get into how it's all put together. This is sort of the Positive Footprints, I guess, story, my little backstory. This was back in 2012, one of our, not our first home, but I think our third home perhaps, where our client came, maybe it's a few more than that, but it's the first one where our client came to us and said, our house is, producing more power than it used. And he sent me this bill way back then. He's getting this bill every year or so. He's on a very good feed-in tariff, of course, which is coming to an end. But this gave me the idea that as long as you minimize the energy use in a home, it doesn't actually need all that much to run. This only had a 3 kilowatt system. It did have gas heating. We had gas hydronics, because this is back in the day when gas was green, and we had gas boosted solar. But this was the start of that inkling of an idea. Then when when the industry moved from 5 stars to 6 stars. There was a bit of an uproar at that stage about how difficult 6 stars would be. So we decided then to create the 9 star series. And this is one of those. This particular house we built for my parents. So I got a bit of the lived-in data. This one had a 3.5 kilowatt system. It had reverse cycle air conditioning, but it still had solar gas, gas boosted solar hot water, and a gas oven. But I would say that this one was carbon. Well, let's say net zero, approximately. Though it's hard to work out because it did have some gas on there as well. Our first all-electric home, where you just got one fuel bill, so it's easier to work out what's going on. This one finished in 2017, and I believe Greg Lamb is on this call. Greg was the lead, our lead carpenter at the time on this job, so he pulled off a great one here. This house has been running for 2 years, past 2017. After 2 years, the owners sent me the bills. They wanted to show they've got 3 adults who live in this home, and they work there during the day as well as sleep at night. And they were managing over a 24-month period to have a net average daily usage of 0.6 kilowatt hours. So just above net zero, but only a smidgen. When you consider that the average, as I showed you before, somewhere around 32 kilowatt hours when you have an all-electric home, this is very close to net zero. That was with a 4.7 kilowatt system and a battery. Of course, systems were a bit smaller than they are these days. Can also be done for renovation, not just new homes. Whenever we do a major renovation these days, we aim for net zero as well. In the areas where we work, north of Melbourne, there tend to be a lot of older weatherboard homes there, where the weatherboards are getting to the end of their lifespan. As long as we get the opportunity to take off the cladding, re-insulate, maybe extend, we can usually get those homes to a net zero footing. This one was pretty close at 4.7 kilowatt system, 3.3 kilowatt hours per day. But when you consider that these days, the average system that's sold these days, the average is 9 kilowatts. If you put a 9 kilowatt system on this house, it would be well into the net zero or net positive territory. Okay, that brings us to today and the Carbon Zero series. So the Carbon Zero series was Positive Footprint's response to all the hoo-ha that came up when the industry was considering going to 7-star and whole of home, and how difficult that was going to be, and with the aim of becoming net zero ready. And we really wanted to show that you could go well beyond that already. So the Carbon Zero series were homes that not only minimize their operational energy and then put on enough photovoltaics to provide the power that the house needs to run annually over a year, but also calculates the embodied carbon in the home, minimizes that, and then puts on extra panels to provide more renewable power to the grid, so that over time that offsets fossil fuels needing to be burnt to provide that power and pays back that embodied carbon debt of the home. Now, sorry about that. Someone's calling. So what I want to do now is show you, we've now got 2 of those homes that have been built and have 12 months of lived-in data. And I want to show you some of that data and how it sort of shifted my thinking a little bit on what a net zero home can offer. So this is the first home that we built. The look of it was a little bit different because the owners wanted something a little bit different, but the floor plan very similar. I won't, on another slide, I'm going to actually go through this graph, but basically what it shows is the house is producing, the green bars are power that gets sent out to the grid. So this is extra power beyond what is just needed for the home from our photovoltaics generating power on the roof. It goes to the home first, extra power beyond what's needed in the home gets sent out. So the green power shows there's a lot, green bar shows there's a lot of power being sent to the grid. Above the line, these red and blue bars, that's peak and off-peak power being drawn from the grid. So you can see very little of that. This house is in credit $500 a year, and that's just with a feed-in tariff of 6 cents. So instead of that $2,000+ of the average bill a year, this one's in credit $500. And instead of contributing 5 tons of carbon dioxide to the atmosphere, this house effectively takes out 10 tons of carbon dioxide by providing free power well, clean power, let's say, to the grid. On top of that, that $500 saving, this house also has an electric car that plugs and charges primarily from the house. The owners and an elderly couple, they try and charge where they can at home. So this car traveled 5,000 kilometers over the year. 92%, this is from the car dashboard, by the way. 92% of the home, 92% of the charging came from home. And of that 92%, 69% came straight from the solar. So they were mostly trying to charge during the day. 15% came from the Powerwall. So this house has a 13 kilowatt system on the roof, and it has a 13 kilowatt Powerwall battery, which is one of the reasons why it's able to have that very minimal demand. The other reason, of course, is because it's low demand to begin with. But that was a saving of $800 on, equivalent petrol fees to drive that car. On top of that, because it's an all-electric home, we don't have a gas meter. There's another $300. If you start adding these numbers up, you get to a saving of, in excess of $3,000 year on year running this particular home. Now I want to look in particular at this graph, because when these numbers came in and I stared at it for a bit, it did shift my thoughts, as I said, on what a net zero home is. So I'm going to go through what I learned. Hopefully it's enlightening for you as it was for me. Oh, okay. So first of all, this bit above the line. Now, extremely low grid demand. In fact, there's hardly anything. In the worst months are obviously in the middle of the year, when it does draw a little bit more power than it uses here. But this equates to about 1.6 kilowatt hours a day in the middle of June. In the rest of the year, it's effectively drawing nothing from the grid. Why is this important? Well, it's super important. I've started to think of sustainability more than just the house itself and what we're offering the owners, but how it fits into the bigger picture. And the bigger picture, as I mentioned when we were looking at all those houses in Melbourne, the bigger picture is that we're trying to put all of industry onto the grid. We're trying to put business onto the grid. We're trying to put transport. We're trying to put all of our buildings and our homes onto the grid, with the idea then that as the grid greens, everything greens, or most things green that are on the grid, in tandem, as a way of reducing the environmental and the carbon footprint of Australia more broadly, and getting to that net zero level. So that's the logic behind it. But if we don't want it to cost an absolute arm and a leg, it's very important that our homes, if we want to be sustainable, minimize that extra demand as much as possible. Now I want to just quickly show you the difference in these two graphs. This is the case study home that we're going to look more at and how it's put together. But this is a second house here that the figures came in not too long after house number one. The difference, these houses are pretty much the same. They look different. The floor plans are pretty similar, however. The sizes are similar. The star ratings are similar. This one had an elderly couple, as I said. This one has a young family. This one has an electric car that also draws from it. This one has a pool in the backyard, and the pool pumps run off that. And really the difference between the two energy profiles is that one has a battery and one doesn't. So if you don't have a battery, this is the sort of net zero I think that we should be aiming for. Not just build any old house and then put on a huge solar system and so have it net zero that way. What we're aiming for is a house that has minimal demand and is still net zero every month of the year. That's sort of the ideal there. So this house, even though it is drawing from the grid, it's only using about a third of the power of the average home, because its inherent demand, just from its good design and the efficiency of the appliances that we put in there, means that after dark, when there is no solar to supply the home, that demand is low. But still, when you look at both of them, I didn't in the past. I was a little bit skeptical of batteries, I have to say. And though we've had them on projects in the past, I've never really pushed them hard because it always seemed to me from the homeowner's point of view that you just about pay off the battery by the time the battery's finished its lifespan. That the payoffs was never quite there. But really, when you look from from a society point of view, you have so much less demand on the grid if you can use most of your power at home. So this house is a very low demand on the grid, but it's also a very resilient home. Resilience is, this buzzword that's been passing around for the last couple of years in the sustainability movement. What happens in the future when we have more floods, more fires, more problems, and there's potentially blackouts? We're after resilience. And if you look at this house, effectively, this house could just go offline and just run on its battery for months on end. That's a huge amount of resilience from a net zero home. The other thing to note about this graph is the amount of power that it produces. So there's enough power here. Again, when we're talking about some sort of emergency, there's enough power for people to come and charge their cars here if they needed to, or it could run, as it says there, enough power for 2 equivalent homes to run. So I'm starting to think of net zero homes as energy hubs. Now, just on that there is a little bit of pushback at the moment, and those people who've installed solar panels recently, those builders out there who've installed solar panels, they may have found that it's a little bit more expensive at the moment because you need to have one of the new inverters that has a curtailment function. What the industry is worried about now is too much solar potentially being put into the system during the day, so that if it comes to pass, there's too much solar, they've got a capacity just to turn that off to maintain the right voltage within the system. So 2 things I'll say to that. One, producing the power is not something we, in my opinion, that we should be stopping. What we should be doing is trying to harness the idea of batteries, and in the very near future, electric cars, which are simply batteries on wheels. In fact, a standard electric car has a battery about 2 to 3 times the size of the Tesla Powerwall that went in here. And of course, typically they're not doing anything at night. What we were waiting for is something called V2G integration, vehicle to grid integration. But I'm glad to announce that went in a month or so ago into Australian Standard 4777.2, not one that we really need in the building industry, but one that the industry needs to start creating homes that can not only take power from the creating cars that not only can take power from the grid, but can also supply back to the grid and potentially supply back to homes as well. And that, so what I think, this is my wish list over here for the government. My wish list is that the government can start incentivizing batteries a bit more. I know that most of my clients would actually go for batteries if there was a rebate on it. At the moment in Victoria, there's like a payback scheme, but it's not really a rebate. But if there was, a few $1,000s in there, I think most of my clients would jump on that. And the benefit for the system of getting the owner involved and that storage behind the meter really limits the need for extra infrastructure on the other side of the house, out in the street. So our homes as an energy hub. Also, hot water systems. I wrote a post the other day. Hot water systems being 25% of the energy we use. All hot water systems should now be charging during the day. So there's a big tip. If you're not already to do it, find a hot water service, an electric heat pump hot water, hopefully, that has a timer on it at the very least, so it can charge and be set to charge during the day. Make use of all this power that gets put in, this renewable power that gets put into the grid as a way of time shifting that power usage. All right, what else did I learn? Well, this house exports to the grid 9,224 kilowatt hours exported. times 6 cents feed-in tariff. That's how you get the 553 in credit instead of the average electric bill for Victoria, 2,228. And when you work it out, it exports 20 times more power than it imports. And this sort of, just looking at this, sort of blew me away. So I also see net zero homes as now low cost living, lifestyles. Not only does it save that much, but you can plug things into it like cars and you can save even more. And of course, no gas meter. And lastly, the house is offsetting 10 tons of carbon dioxide instead of creating that 5 tons of carbon dioxide. So it's a carbon negative footprint. So when someone asks me now, what is a net zero home? This is what I'm answering. It's a resilient home. It's an energy hub. It's a low cost living lifestyle, and it's a carbon negative footprint. Okay, that's the operational performance of this particular home, and where we could potentially move to with just a little bit of incentive. By the way, if the government wants to put some incentive around getting some more electric cars out there, once we get this V2G happening, just make charging during the day free. Imagine what an incentive that would be. People be charging their cars during the day, come home at night time, and then the cars, part of the deal of that is part of the battery could be used by the network providers to export to the grid or help balance the grid. Just a couple of ideas I had looking at this particular graph. All right, let's look embodied carbon, just to finish the performance of this home. So I ran this house through the True Zero Carbon spreadsheet, which is the spreadsheet I developed in conjunction with Melbourne University, who created the EPIC database. It works off the EPIC database. We developed this for the True Zero Carbon Challenge. This home has an upfront carbon component of 173.6 tonnes of carbon dioxide. So still a lot, and hopefully I'll get some time to go through that, seeing how my voice holds up. But a fair bit less than that, well, 290 I said before, 250 to 300 tonnes, somewhere in there, the average home. But if you look at that over here, just on a simple payback, 173.6 tonnes of embodied carbon. At the moment, it's offsetting 10 tonnes of carbon dioxide per year, 17.4 years, if it was a simple payback and everything remained the same. Of course, the grid may green over time, so I might discuss some of the implications of this as a strategy a bit further on. This gives you a sense of how the house is performing, and on a simple payback, yes, this house is, I would say, a true zero home. This is just some of the True Zero Carbon challenges. So the Design Matters National, we've now had, I think, 30 teams go through the challenge. Each one of them has been able to meet this same challenge of creating a true zero home that pays itself off by 2050. That's the actual challenge. But this just goes to show that if you put the right team and the right education together, it's not particularly hard to create these homes. And it's just like riding a bicycle. Once you know what sort of appliances to choose from, what sort of what sort of scores you're going for, and you've got the right team around you that can provide that, it's easy to rinse and repeat, rinse and repeat. All right, let's get into maybe the nuts and bolts of the whole of home approach. That's the approach that I take, and if you look at the SBA website, that's the approach of the information on there as well. And what is the whole of home approach? It's simply going around each of the wedges of this pie and doing what we can to cost effectively minimize the energy needed. All right, so the wedge I always start with is the space conditioning wedge. And there's 3 different steps that you need to do to minimize this step. The first one is do a good design. And by good design, I mean a design that's designed for climate. In Victoria, we have to get at least 7 stars. The more the merrier, the more you can put on, the lower will be the amount of energy that the home uses. However, having said that, in the True Zero Carbon Challenge, we did have homes that were only 7 stars that then, through careful appliance selection, were still able to meet that True Zero goal. So it doesn't mean you have to get to 10 stars to achieve these outcomes if you do the rest right. So how do you achieve a good design? Well, you simply use passive solar design to design for climate. And it's as simple as, if you're in a cold climate, try and invite the sun in. If you're in a warm climate, keep it out. In that case, try and get breezes to blow through your home, prevailing summertime cooling breezes, hopefully. Shade will be your friend. And if you're in a climate where you have a high daily temperature swing, linked to the mass of the earth, and that will help stabilize temperatures inside. Very simple rules. I'll show you what we did on this home. Well, actually, before I show you what I did on this home, let me just explain how this idea of passive solar design links to the stars. So the stars are simply a measure of how much energy the house takes to heat and cool. And that in turn is a proxy for how well the house is designed for its climate, or how well you've used passive solar design. Our particular home is 8.6 stars. That's why the 8.6 there, the case study home that we're going to look at in just a second. But to give you an idea, if we're looking at the pie, the average home is around about 3 stars. That's if you average all the old homes and the new homes together, you get 3 stars. Of course, if you're in an old home, it's more like 1.6, 1.7 stars for some of the very old homes. If your home's past 1980, you're probably more like 3, 2.5, 3 stars. If you're past 2004, when energy ratings started coming in, then you're 4 stars, 5 stars, potentially 6 stars. And that's if it was built to perform to the star rating, which probably wasn't at those times. But let's say 3 stars. A 6-star home compared to a 3-star home would put you there. So that's how much energy we save. And that's still the 6 stars is still the mandated requirement in some states of Australia. For others, it's 7. So that's why I went to 7. You get a little bit more of a saving on your energy use going to 7 stars. If you get to 8 stars, it's more like that sort of saving, 9 stars, and potentially 10 stars. So you can really see the value of good design in reducing the energy needs of the home itself. And that's why it's important to get a good team around you. So even if you're not involved in the design yourself, you're working with designers and architects who know this stuff, and then they're potentially passing it through to you if you're the builder or you're the energy rater. It's a matter of getting the right. If you don't have all those skills yourself, you haven't got them all in-house. Positive Footprints, we've worked to get them all in-house, but it's just a matter of putting a good team together, and you can achieve great results as well. I should also say that this is the average. It depends where you are in Australia as to what this wedge is. If you're in one of the colder climates, if you're in, Victoria, maybe southern Western Australia or Tasmania, this space conditioning wedge can go up to 60% of the pie. It becomes even more important to get a good design in those climates. Now, our home, of course, was here, somewhere around here, 8.6. Now, these are just indicative, but it gives you a sense of the sort of savings that you're getting for those stars. All right, so how did we achieve an 8.6 star rating on this job? Well, here's the house, here's the floor plan. Simply, you'll notice that north is up the page. We started by just putting the living area on the north. This is really basic stuff. The sun rises in the east, sets in the west. It goes over the north part of the sky, doesn't go directly overhead, travels over the north part of the sky, lower in winter, higher in summer. You can see our eave line there. That eave line is designed to let the winter sun come underneath through windows, falling on that area, but to block it out in summer. The rest of the home, the other bedrooms and utility areas, are more like just sort of insulation on the cold side of the house, keeping that living area nice and warm throughout. The bedroom itself, the master bedroom here, does get a good deal of northern sunlight, and we put up a shade sail that goes up for the summer period to provide some nice shading over that area. Pretty simple stuff. Now, on a block, there was one tree, but don't I want to bust the myth, I guess, that this is a perfect site, or almost a perfect site, let's say, but you don't need a perfect site to get to 7 stars or even 8 stars. If there's something in the way, you can usually, as long as you're looking to try and place your main living areas in an area that can get some some solar gain, then you'll do pretty well. And very few sites I've found over the years don't give any solar gain. Most, because remember, the sun is rising, it's moving across the sky during the day. You usually get a good opportunity to place those living spaces. Then, because we're in a cooling climate, we're trying to get the sunlight into, sorry, we're in a heating climate. What's called a heating climate, trying to heat most of the year. We're trying to get sunlight into those living spaces. And so you can just see we've banged in some nice big windows there. And you can straight away see which way is obviously north, that elevation, and the other elevations. Windows are primarily placed for access, windows and doors access, and for good ventilation pathways through the home. And of course, the other thing that we always try and do, at least in the Carbon Zero series, is to choose good quality windows. On the SBA website, we recommend U values below 3 if you want to get to 7 stars and above reasonably easily. We typically go to the pointy end of window performance, and these are the windows that we've been putting in, the Thermatech windows. U value of 1.7, the lower the better. That's a good U value on the Australian market for a non-fixed glazing window, for a sash window. Solar heat gain coefficient, we're trying to get as high as possible. That's actually not a bad solar heat gain coefficient for a double glazed chunky window like this. By the way, on the website itself, if you go into the Windows section under Step 1, Good Design, you can find all about how to choose windows, U values, solar heat gains, how to use the Windows Energy Rating Scheme database to find the best windows. So check that out. You'll find a Thermatech there at the pointy end. PVC, very durable material, very robust, and of course, they recycle it all the time in Europe, and recycling is already starting up in Australia. Once we get more homes that the PVC windows are coming out of, no doubt that will also be recycled. PVC is a very recyclable material. All right, and what you're looking at here is the house in action. I guess this is just passive solar design, but it's so simple, people. It's just trying to get that sunlight. If you're trying to heat your home for most of the year, try and get that sunlight in. We also put in a little bit of mass, and there in Step 1 Design, you can find out all about how to use mass and good rules of thumb to use there. All right, so knowledge base. This is what you need to know, or your designer needs to know, or someone in your team who's doing the design needs to understand. To get a good performance and a high performing home, you need these things. You need to know the 5 rules of passive solar design and how to use them in different climates that you build or construct or design in to minimize heating and cooling needs. And where do you find the answers? Where do you find that information? You can go, as I said, to Step 1, Good Design, and you can see the 5 rules of passive solar design are all there. You can click on them. It'll give you a big rundown of those things. The other thing I'll point out is the SBA 7-star cheat sheet. You can download that as well. This I'm not sure if Ham said in the intro, but I'm, as well as being a builder, I'm a long time thermal performance assessor since 2004. Basically, all the tips that I know about thermal performance of homes are put into this cheat sheet, along with other tips from other people, other energy assessors. So thank you everyone who's contributed to this. But not a bad idea when you're doing a design. It will to read through this and see if there's any red flags that are coming up in the design. If there are any red flags, get your design off to an energy assessor just to check it before it goes too far and gets fixed down in engineering. And of course, the other thing I want to point out is that under each step, there's a webinar section at the bottom of the menu there, and it will have relevant webinars for the information on. It's always best and most current to read the information, but at the moment, if you go to the webinar section, there are these net zero home webinars that I did a couple of years ago. Solar Victoria has dusted them off and bought them from the South Australian government, so they're now free. The module number 1, all about designing for thermal performance. So if you're a listener rather than a reader, you can get on there and you can find out about that. All right, the other bit of information that you'll need to know if you want to have high star outcomes, there is one secret, as it says, that you need to know. And it's simply this: do 2 ratings. Do 2 ratings. So you have to do your compliance rating at the end. You'll still have to do that. But don't just do that one at the end. The thermal performance assessor can do very little at that point. All they can do is maybe upgrade insulation, maybe, specify triple glazing or more fancy glass. That's about it. At the end of the process. And so what that means is typically minimum compliance if you go that way. But the real power of the NatHERS House Energy Rating software, and I've been talking about NatHERS basically because that's what I use and that's what I rate with. But of course, if you're a passive house person and you're using Passive House Plus or Premium or FIAS 0, it doesn't matter as long as it's a whole of home software. You can still go to one of those energy assessors and get that early in your concept design. That's when you want to do it while the design is still fluid. Get an assessor to look at it and try and improve it. So what can assessors do now? With the new whole of home software, thermal performance assessors can create an optimization report. And at Design Matters National, we've been educating assessors how to do that, of things that can improve the design further, present that to you. Really valuable design concept stage. Software can do free, it's always been able to do this, but no one's really taken it up to look at it much. But you can do a free running mode analysis where they turn off the heating and cooling, just look at what temperatures the house is likely to have under those scenarios of no heating and cooling. The software can now load in future climate files. So we can look at different scenarios of carbon dioxide levels in the atmosphere and look at how the home is likely to perform under those climate scenarios. Importantly, now that there's whole of home in it, which is the fixed appliances, the hot water, the space conditioning, the lighting, and the heat and the cooking appliance, and pools and solar panels all go into the new software. But you could potentially look at different appliance suggestions, and thermal performance assessors over time will start to know a bit more about what efficient appliances are in the industry and potentially give suggestions, or at least try things out that you want to try and see how that affects the performance of the home. Peak heating and cooling plant sizing is possible through the software. If you're an assessor watching this and you don't know how to get that, because you get that from the output file that the software generates, you can go to SBA Step 4, how to size up space conditioning units. There's a special little download just for assessors there. And lastly, this is probably the most important question. You should be asking your assessor at design concept stage, if I want this design with this appliance set to be a net zero outcome, what size PV system would I be looking at? Make sure you got the right amount of roof space to achieve that. All right, so assuming you've done good design, and here we did, how much would you expect to save on average? Well, I've got that dotted line in, you saw that before, but the answer is still at this stage, typically we don't know, because it depends on another thing. It depends on build quality. If the house is not built well, it won't perform to its energy rating. And this is something that the industry and SBA in particular have been trying to change, and things are starting to move, I believe, in the right direction. But you want to get a team, or you want to teach your team, or if you're a designer, you want to choose a builder who knows how to build to achieve the thermal performance. And here we have the Positive Footprints Thermal Ninjas, who are simply our carpenters who've been through the process many times. Here's some examples from that case home. And this is insulation is really, I think, just about number one, trying to get the insulation flush and well installed throughout. And as we move to offering net zero homes, it's very important for the builder, from a risk management point of view, that you start getting these photos so that you can back yourself if there's any issues. You can say, well, I installed everything as I was supposed to. Note here the foam over the steel to try and stop a little bit of thermal bridging there. A little bit of AbleFlex kept on site can really help with thermal bridging, little bits of thermal bridging you find, or at least help, if not stop completely. This particular home, we had an interesting a mixture of a slab on ground, and we also had, actually had a waffle slab that moved into a Bondex slab when the ground fell away a bit to try and keep that single level. Now, from the design point of view, and this I would always suggest that builders or designers just look at your designs that you've come up with, especially once you get the engineering back, and think of it from an energy flow point of view. Are there any spots where the insulation is broken? Are there any energy spots where you're going to get some thermal bridging of some conductive material passing through the insulation layer? And here we were always going to have insulation under the slab. There was 125 mil foam, but at the I-beams there was going to be a bridge, and on all the external brickwork as well, there was going to be a thermal bridge. So we put some 19mm structural rubber just to limit the heat flow there, not to stop it completely, but definitely to slow it down a lot. A little bit of edge insulation at that slab edge, and then wall insulation. And this is what it looked like on site. You can see our subfloor recycled brickwork. Complete sheets of polystyrene, which can, at the end of the build, if you take down that brick wall, you can just slide those out because they all just sort of slide into channels, and the structural rubber there. Now, I do want to stress this particular build. This is not a common way to do floors. And so there's a cost to this, but really what I'm presenting today shouldn't cost, apart from maybe if you put the battery in at the moment, and maybe the photovoltaics. Everything else is pretty standard for the house. In fact, the other home, the other Carbon Zero series home, that's simply on waffle pod standard construction. This is another thing to think about that we had to consider on this job too. We had a paving slab, which was going to have a deck over the top of that, abutting onto the house slab. And you want to make sure this is done in separate pours, or that you have insulation in between. Otherwise, what happens at night, the paving slab outside gets very cold in Victoria, and it will just, if it's directly linked to the house slab, it will just suck heat out. Now, these things aren't taken into account in NatHERS. They are in PHPP from what I understand, but it only takes a bit of an eye to think about these things when you're looking at the design, and a chat to a good engineer who also is on your team trying to get a good thermal outcome, to come up with a solution and to note the things that need to be done. So we put some insulation R1.5 XPS just through that section. What else do we do for thermal performance? Well, in standard construction, our home is just standard construction. We do the wall wrap, well on the outside. We're still using foil back blanket on the ceiling. So like I said, standard construction. So for our tightness barrier, we're working on the plasterboard and trying to make sure that the plasterboard is reasonably tight. Square set cornice is a great tight long-term seal. Easy reveals to windows. Similarly, it's a tight seal rather than architraves, which paint can crack over time. What else do we do? We're downlight free. There's no downlights in this home. They're all pendants hanging down. Ductwork free because we're using reverse cycle air conditioners. Backdraft dampers to exhaust fans. All these sort of standard things, but we're just putting it all together. I think we had 2 cavity sliders sealed so that we don't have a literal hole in our plasterboard to create an air pathway, and all plumbing penetrations corked nice and tight. This particular home had we do blower door tests, and I would suggest, if you're not yet doing blower door tests, you don't necessarily need to do them all the time, but it's good as a builder to know how tight you're building. For NatHERS, we're only trying to get under 10 air changes. I'm trying to get somewhere shooting towards 5 at the moment. Back then when I did this home, we were using Daikin US7s throughout. Unfortunately, they're not available on the market anymore. But those Daikin US7s actually had a fresh air intake as well, and they were excellent. They also had a dehumidifier that worked both in heating and cooling mode. Great units, but in their wisdom, Panasonic decided they were too complicated for the Australian market and took them away. All right. So if you want to get your home performing on the ground as per its energy rating, you need to get a builder or a building team, or you need to be a building team that understand where buildings fail thermally and then how to build for thermal performance in the building technique that you're using. Under step 3 of the roadmap, we have a full section on standard construction, where that fails, and we have this builder's thermal performance checklist. Once again, I've taken a bit of time putting this together over the years. This is something that you can download and you can change as you like. I find this particularly useful for builders who want to give something, a quality assurance checklist to their trade or their site manager, say, on site to tick off and make sure things get done. The idea is, especially with standard construction, it's important to make sure that little bits and pieces are done before the next stage. You know, if you haven't caulked the plumbing penetrations and the wire penetrations before the kitchen cabinetry goes on, you're not going to be able to seal it later because there's too many gaps and cracks around the cabinets. And once you put a blower door test or the wind's blowing, you'll feel breezes coming out where you don't want them to. Just little things like that. This performance checklist is full of that. I know a lot of designers are also starting to use this and put it in their design documentation. So yes, consider having a look at this if you haven't already. The website goes through each one of the areas where building fails and gives a rundown of what the control measures are for that. Once again, if you go down the bottom of that step number 3 there, you'll find a webinar link that can take you out to Net Zero Homes, module 2, which is all about how to achieve on-site performance. These were done a little while ago though, so the website is probably the better information to go from. All right, so assuming you build the house to quality, as our thermal ninjas do, you can expect, the sort of savings that you'd expect from the energy rating to actually be on site. And you can see how much of a saving that we've done there. But there's one more step on this particular wedge, and that comes down to the heating and cooling plant that you put in. This would be how much heating and cooling energy is required for standard plant, but we can choose much more energy efficient plant to reduce this even further. And the appliance of choice, as I mentioned, is reverse cycle air conditioning. Reverse cycle air conditioning is a type of heat pump, and heat pumps are a game changer for the sustainable all-electric home. Effectively, heat pumps use about at least 2/3 less energy than standard, say, ducted heating. They can heat with about 1/3 the energy of ducted gas heating, say. They're extremely efficient at what they do. And they can get that efficiency because they've got an inside head, they've got an outside motor, and they've got a refrigerant that just runs around between them. And all the refrigerant does, it comes outside, it goes through an expansion coil, I think. It goes through an expansion process anyway. And that makes it very cold when it's outside in heating mode. There's a fan that blows across some very cold pipes with the refrigerant in them. The heat from the air goes into the pipe, into that refrigerant, and then it just runs around inside, goes through a compressor that squashes the refrigerant, makes it very hot, and goes through the head unit. A little fan blows across little pipes at the back with the hot refrigerant blowing through it and blows the heat out into the room. And so it's just like a sponge soaking out heat in heating mode, soaking heat out of the air, and then coming inside and just sort of squeezing it out inside the house, a bit like a big sponge. And in cooling mode, it just works the other way around. And in doing this heating or cooling, all that the motor is doing is just running that system. So it can use a low amount of energy, but still transport a high amount of heating or cooling. All right, so to actually implement a strategy where you're using efficient reverse cycle air conditioners, these are the things that you need to know, or that your team needs to understand to choose your system wisely. You need to know how to size up the required units. You need to know how to choose efficient units once they've been sized up for what kilowatt capacity. How do you choose efficient ones from inefficient ones for your climate zone? Check the refrigerant. You'll notice here our multi-split has an R32 refrigerant. That's a reasonably low greenhouse greenhouse gas potential, what do they call it? Global warming potential refrigerant, which is important because at the end of life or as a system, you know, goes through its lifespan, it can leak some of that refrigerant, and some of those refrigerants are very high in their own global warming potential. So you want to choose wisely your refrigerant. And lastly, as we move into NatHERS whole of home, to actually do the process, the assessor needs the relevant data on their plan. So you need to know what information to put on a NatHERS, to put on your plans, just to assist that NatHERS process and to make it nice and quick for the energy rater. And where can you find that? You can find it all under step 4 that goes through all the fixed efficient appliances and gives the information you need. In this case, energy efficient heating and cooling. If you click on that, you scroll down and you will get links to all of that good stuff information. You'll also notice that there is a link here for air conditioner details to put on plans, and that will allow you to download templates if you want to use them. And the templates also have instructions of how to fill them in, where to get the information, what information to look for to make it nice and easy. So assuming, you know, you use efficient reverse cycle air conditioning, as we did in this, this build, you can expect to provide the required heating and cooling with only a fraction of the energy to do it. Something like that. So you can really see through good design and a good appliance choice there, we've really made mincemeat of how much energy the average home would use for the process of heating and cooling. All right, let's move on to the other wedges. The first wedge is the hardest. The other wedges are easy because they're just appliance substitution. So in the second wedge, water heating, 22%, approximately a quarter of our energy use goes to water heating. And there's two things to consider, two main ways to limit the demand. One is to choose hot water appliances that themselves are water efficient, so there's not so much water to heat up. And the other one is to choose an efficient heat pump hot water system, or potentially solar hot water systems in the right climates are also very good at providing low energy hot water. In our case, this is what we provided. We use these Methven Rua shower heads. They look pretty funky. They're a 4-star hot water shower head, and they give a pretty good spread of the shower by banging the droplets against each other. So you're using less hot water. And the shower, why the shower? The shower uses half of the hot water in a house typically will go through the shower head. Now, this is not part of the NatHERS scheme, the shower head, but it does make a difference. So this is one way you can actually get your home performing even better than maybe what the simulation says it might. And the other way is to use efficient heat pump hot water. In this case, we used a standard hot water heat pump. Importantly, the Sandons, you can unscrew the lid and you can change the time on them to set them to heat during the daylight hours. And there are other systems out there that make it even easier for homeowners to set the time of heating on the hot water units, to make use of all that renewable power that's being put into the grid by solar systems and wind farms and different things during the daylight hours. So the knowledge base here, what do you need to know to make big savings on hot water energy usage? Well, you need to know how to choose efficient shower heads. You need to know how to choose efficient heat pump hot water for your climate, how again to check the refrigerant, what refrigerants are good ones to look out for, and again, the information that the thermal assessor will need on the plans to do a speedy rating without a lot of calls backwards and forwards seeking information. Once again, step 4 is where it's all at. Scroll down and you'll see the information that you need to find out. It's all there. So assuming you do those two things, efficient water head, as we did in this job, and a heat pump hot water system set to daylight timing, you should be able to make this much hot water. Well, first of all, you'll need less hot water because the efficient shower head, but also you can make it more efficiently because once again, this is a heat pump hot water, which means it's very efficient at shifting heat into the hot water tank. There's a better description of that again on the website and in the videos. But this is the sort of gains that you can make simply from those two steps. Approximately 2/3 of your hot water energy use is taken away. And you see how we're starting to eat our way around this pie in a whole of home method. Okay, lighting. Now, lighting is a very simple one. Simply use LEDs. Now, most new homes these days, they'll all be LEDs anyway. The other thing to consider is to try and use pendants rather than banks of downlights. Why use pendants and wall lights? The reason is that a pendant spreads its light out much better than downlights, so you typically need less bulbs and you can cut down on your watts per square meter. I didn't go into how the software, NatHearst software works, but it does rank your home against benchmark appliances. And for lighting, the benchmark it's ranking against is 4 watts per square meter. So you're trying to get less than 4 watts per square meter to sort of get ahead and get a good score on NatHearst there. The other important reason to try and minimize banks of downlights is if you're using the plaster as the tightness membrane in standard construction, you're wanting to limit the number of penetrations. Every time you put a penetration through that, you're sort of loosening the house. And you don't want to loosen the house too far because then it will go outside of that NatHearst assumptions for the tightness of the house, and it won't perform to the level that the software assumes. If you do want to put in downlights though, make sure they're ICF or IC rated and they have a little sticker on them or a stamp on them saying that they can be covered completely with insulation. The other thing that I would do is make sure the springs are nice and tight and put like just a little diaphragm on the back side of the light so it what's the word, acts as a gasket and really seals it off to the roof plaster, so you don't get this heat loss under wind loads. All right, so what do we need to know there? You might need to know, especially if you're thinking about how to minimize your lighting needs, you might need to have a think and learn about how to size up lighting using pendants and LEDs. And the other thing is, again, how to work out how much watts per square meter your house is using to put on your plans for your NatHearst assessor to put into their documentation into the software. Once again, you'll find that under energy efficient lighting, scroll down and there's links out to a lighting table and some information on how to, just some rules of thumb when designing with LEDs and pendants. And if you do those steps, again, as we did in this house, minimize those, minimize lighting with pendants, we were able to, again, you just get a little savings, only a little wedge there. So you only get a little saving, but again, you've eaten away at that. Let's move on to that cooking wedge. We're nearly through this circle. Again, another easy one. There's only one appliance to consider here for cooking that's more efficient, and that is induction cooking. Gas cooking, you lose quite a lot of the heat of the gas as it flows up and around your saucepans and your pans. Induction cooking is more efficient, about 50% more efficient at getting that heat into the food itself. So here you can see we just use an induction cooktop. They have many other benefits as well. Gas, when it burns, actually creates water vapor. So in the home, you're trying to limit the amount of water vapor that's being made. So that's one thing. Incomplete gas burning also produces nasty or leaves nasty chemicals, puts them in the air. Not great according to the Asthma Foundation. So some good reasons to go induction cooking. Very easy to clean. And perhaps the one that I like the most is that this is usually the last gas appliance in the house to swap over. And if you swap it over, you can say goodbye to the gas meter. You only have 1 meter. You it's easy to see how much energy you're using, and you can say goodbye to that $1 a day connection fee of the gas meter. The information you're going to need to know here, if you haven't done it before, there's different induction cooktops. Some of them require different amperage cables. They need to go in at rough-in stage, not later. Also, if you are going all electric, there's a very good chance that your electrician's going to tell you need to go 3-phase. So just some things to consider. That actually has some good application later on for the amount of solar you can put in, the amount you can feed back into the grid. And again, there's some information to put on the plans for the assessor, and you can find that on the website. I keep directing you to the website really just to show you what's on there, and that the information that is needed here is there, for when you need it and when you want to find out about it. But if you go induction cooking, you can make a little bit of a dent into that wedge as well. Now, the last wedge is the appliance wedge. And most builders, most designers probably don't get too involved necessarily in appliances. But in the Carbon Zero series, we do. What we do, the Carbon Zero series comes as like a project home package, if you like, and it comes already with the major appliances. And the major appliances comes with an efficient television, an efficient fridge, an efficient, don't think freezer. The fridge has a freezer, efficient dishwasher, and clothes washer. Yeah. Oh, and a dryer. Yeah. Comes with all those things already priced in. Why do we do that? What you're looking at here is, again, a pie graph. I like my pie graphs. This is the pie graph of that appliance wedge, the plug-in appliances, and it shows that half of the plug-in appliance load are these sort of big white goods that you typically will go into a new home or a major renovation. Now, what we found just from the 2 homes well, we're building another one at the moment, but we've found that clients don't necessarily like the appliances that we've chosen. But that's okay, because once we've set a very efficient appliance and we've explained why that appliance is efficient, clients will typically go out and they'll choose their own thing, but it will be very close to the same efficiency. A simple bit of information, this is one that I like to show them, is the difference between the best in class and the worst in class of sort of your major appliance sizes, and a 10-year operating. I don't know whether this is still on the web. They used to have this here at energyrating.gov. You could use the calculator and send clients there. But there are big energy efficiency cost gains for clients in choosing higher stars. The rule of thumb there is for every extra star on an appliance that you choose, on these sort of appliances that last sort of 10 years, will be around about a $50 saving per extra star that you get. Now, there's some information on how to choose efficient appliances there. You could always send clients potentially to this site. There's also another template that you can download, and this is actually written to clients, just giving them some information that if they want to go and choose their own appliances, just to let them know that, look for the higher stars. That's it. And there's you can fill in yourselves, if you want to, appliances of choice that are energy efficient that maybe clients have used before and said are pretty good, and you can build up an efficient list over time. They do keep changing though, so you've got to sort of keep on top of it. So assuming you make some effort to sort of educate clients, maybe suggest a few efficient appliances, and tell them that the stars do make a difference, and that you've built this house and you're really trying to get this house to perform really well, you'll find that most clients will come on board and not choose terrible appliances, and you can get a bit of a bite out of that wedge as well. So look what we've done here. We've gone around each of those wedges there, done what we can, nothing that is, super costly, but we've done sensible decisions just to minimize the energy needs. We haven't changed the functionality at all. The house still functions exactly the same. We've simply changed the amount of energy that the home uses. All right, the last piece of the puzzle is to offset with photovoltaics. So, how much should you put on for net zero? So, like I said before, the way to know is at that design concept stage to get the thermal performance assessor, ask them that question and see what number they come up with. From our sort of rule of thumb, the homes that we build around about 200 square meters, these ones here were unfortunately a little bit bigger. 260 square meters or so. But we've found that somewhere around, as you saw before, somewhere around that 5 kilowatt level, homes start to break even on a yearly budget, maybe not every month. But you can check that with an assessor. Whatever number they come up with there, I would always add on at least a kilowatt to that number, just to account for real world fluctuations and different energy use within the home. Add on a kilowatt. The other rule of thumb is if you've got an electric car and you want to charge it at home, another 2 kilowatts of panel will charge most cars to drive an average of 50 kilometers a day, an electric car. So there's 2 kilowatts to add on for the car. And if you're trying, like we were for the True Zero series, the Carbon Zero series, to create a home that pays back its embodied carbon debt, another 2 kilowatts on top of that should do it. And that comes to 10 kilowatt system. Now, a couple of years ago, that would have been a big system. Today, I'm not sure if I said it before, but the average kilowatts, yeah, I did. The average kilowatt system that's sold on the market these days is a 9 kilowatt system. So not too far from the average there. In this case, the owners decided to, as owners might, upsize a little bit once they got their deals, a 13.2 kilowatt system. And we usually put an amount of money aside for a 10 kilowatt system, just as a provisional sum. And then at the time when we're up to putting it in, that's when we get some quotes. The way we do it, the owner gets the quote and we just take that money off the contract, but there's an allowance there for it. That's the way we do it. The owners chose, in this case, a 13.2 kilowatt system, a little bit of a bigger system. The other thing that they also chose was this Tesla battery to combine with it. And like I said, that's really what allowed, along with the lower demand and operational needs of the home, combined with the battery, that's what allows this house to be so energy independent. And also the car charger acts as a way of shifting, some of that power that's created during the day to be used at other times. And what do you need to know for your knowledge base to do this well? Well, if you go to step number 5, there is a section, PV, what you need to know, and it outlines all the different things that you need to know there. And assuming you follow those rules of thumb, you should find that the home is producing at least as much power as it needs over the year for a net zero outcome. All right, so what have we achieved here? We've achieved net zero home. Yes. We've also achieved a home that is a power hub. We've achieved a home that is resilient in the case of blackouts or emergencies. We've achieved a low bill lifestyle for the clients, and also from a social point of view, we've achieved a low grid demand as we need as we're adding these next 1 million homes onto the grid. How are we doing, Ham? Should I push on? I finished all the net zero stuff. The True Zero, the embodied carbon part is not too long, maybe another half an hour. What do you reckon?
Well, I have been having a chat with a few people offline here, and everyone was keen to go past 20 past 6. It is now 20 past 6, and I guess from my side, having a couple of young kids that I probably need to go and jump into parenting shortly, I wonder if you and I could even jump on at some point and re-record, like record
I
that
think
one and
so.
post it.
Yep. Yep.
Or
Yep.
or let's do another one. I mean, I think this one, like given the time of the year, it's been super popular, and we've had a heap of people jump on. And do you know what? Not many people have jumped off after 6 o'clock, which is great to see. So I think from my side, I reckon we do. I reckon we do another one, mate. That's That's my gut.
I think also it allows us to do embodied carbon justice because there's a little bit of background information to really know what different strategies there are to choose from and what has an effect and what doesn't have an effect. And so, yeah, let's do it another time.
Awesome. Um, so there were a couple of questions here which I have actually jotted down, but I probably won't open it up to questions for everyone because I am kind of keen to jump into some parenting. But Jeremy, there is one question here. Is there an energy rating system that can be used when designing and building alterations and additions to add confidence in investing in better built outcomes?
Yeah, NatHers. NatHers does it. That's exactly what we would use. But it is a little bit more complicated in that if you don't get 7 stars straight away, you sometimes need to do a before and an after rating on the home to sort of prove compliance that you've improved the home. But yeah, that's what I'd be using.
I mean, we have a bit of a mantra in house at Sanctum Homes. Model often, and keep going until you've got a really good outcome. And you can do that through PHPP or through NatHers. So,
No,
yeah,
100%. And I tried to say that I'm just a NatHers man, but you know,
yeah, yeah, yeah. Oh,
these are all just tools. They're all based on building science. They have some different assumptions, and we can argue about different assumptions. That's fine. But if you get someone who's experienced in using the tool, and the tool shows a solid direction in the changes it's suggesting, then that's something you should probably take on board.
I think the long and short of it is model. Whether that's NatHers, whether
Mm.
that's PHPP, whatever, you just got to model. Look, I'm,
Yep.
I'm going to round it out. Jeremy, that was awesome. Thank you very much. I certainly have learned a lot today, and I feel like I do walk this walk often in my business, and yeah, it's always great to hear lived in projects. I think it's really valuable. Thank you to everyone who's joined us today, and thank you for everyone for hanging around for almost an extra half an hour. Again, big thanks to Thermotech. As Jeremy said, they were part of the projects that Jeremy talked about today, and they are a platinum sponsor for Sustainable Bills Alliance. Cheeky plug, we have a new episode out for Sustainable Builders Alliance, or Sustainable Builders Yak podcast. We've got the legend Paul Haar on that one. I'm yet to listen to that one, so I'm really excited to listen to that when I'm heading to site tomorrow. Before I round things out, though, I want to extend a massive thank you to everyone who has supported us this year. I feel SBA is just gaining huge amounts of traction, and we are just getting bigger year upon year. And we are super excited next year because we do have some pretty decent changes that have happened in SBA. We've recently appointed a new COO, Beck Kempster, and we're really excited to introduce her to you next year. And we are going to be shifting to a membership model. Now, I hope I didn't let the cat out of the bag there, Jeremy, but I'm really excited about this one. And we are going to continue to be holding events next year. Now, we have huge ambitions for these events next year. We're still going to be holding them at the Better Building Exchange with our mates at Hit Burst Hype. But we actually have some pretty significant major partnerships that we've fostered that we can talk about early next year. So keep an eye out for that one because we're going to be holding it at these locations. And I'm actually catching up with Beck tomorrow to map out our events for 2025. So, Jeremy, I believe you've been working on an events page for the website. Is that correct?
Yes, so it's actually live at the moment. It needs to be filled up with stuff. But if you went onto the website now, by the way, past webinars are on there. You can get through to our podcast that way as well. So, and there's an events page. So there's other stuff on
Yeah.
there. Check it out.
Yeah. So the events page well, I guess there's going to be a few placeholders there, and we're going to try and land on the dates pretty close, but just bear in mind that that might change just a little bit as we get closer, but we'll lock them in. And we will actually have a function on that events page where you can sign up to those events. We're going to be doing some factory tours and site tours next year, so keep a lookout for that. And I'm going to wish everyone a Merry Christmas and a really safe holiday season. And for all you joining today, we will post this on our our website and YouTube channel, and that will be available for free. So www.thesba.com.au. Jeremy, thank you so much, and thank you everybody for joining us today.
Thank you.
All right, we'll catch everybody later. We look forward to more webinars and live events in the new year. Cheers.